Greetings. Welcome to Week 2 of GIS 4630, Public Domain Data for GIS. Joseph Kursky here with you. Greetings. During Week 2, you will have the opportunity to learn about spatial data models, major portals for vector spatial data, and considering issues of data quality. Now, data quality issues run throughout our course, but we're going to start getting into it right here in Week 2. You will also have the opportunity to download and use XY coordinate data, in this case, earthquake epicenter data from the USGS National Earthquake Information Center. This week, you'll be reflecting on your readings, participating in this discussion, finishing Lab 1, and doing the short activity that I will describe in a moment. You will also finish reading Chapter 2 in your textbook if you've not already done so. This will provide context for our exploration of vector data sets and of data quality. You will also finish Lab 1. Just as a refresher, Lab 1 is the lab where you examine the distribution, source, and spread of zebra mussels, an invasive species, a waterborne invasive species. So you're going to be using public portals to download and format, project, etc. data, and then you're going to be using that data to make several decisions. You're going to be running several analysis tools inside ArcGIS to do that. Also, you're going to be completing this short hands-on activity that I will describe in a moment, and it has to do with XY data. Now, XY data is everywhere. What I mean by that is it's positional data, it's locational data. It could be street addresses, it could be lat-long coordinates, it could be coordinates in another type of coordinate system like the UTM coordinate system, but basically it's a position on the Earth's surface. Now, these XY coordinates are gathered with GPS from earthquake epicenters, for example, city fire hydrants, locations of stream gauges, and much more. This week, you'll have the opportunity to bring in some of this XY data from a public domain site, the USGS National Earthquake Information Center. I used to work at the USGS, and I would give tours of this Earthquake Information Center periodically. Fascinating place. If you ever get to Golden, Colorado, I highly encourage you to take a tour. But you'll use these same procedures or similar procedures for any XY data. So think about XY data as sort of a treasure trove of information for GIS. And what you're going to be doing is you're going to be downloading this earthquake information database, and you're going to be querying the data set for a certain week. I'm going to have you either look at the last 7 days of earthquakes or the last month of earthquakes. But I encourage you to come back to this site because you can actually query the data set to come up with major earthquakes or over the last year or above 6.0 in magnitude or deeper than X depth, kilometers below the surface, and so on. So it's a great way of getting into what kinds of data you can actually bring into your GIS environment to make decisions. But more importantly than just downloading and using the data, I want you to assess the patterns that result, right? That's what we do with GIS, is we want to look at patterns and relationships and trends with the data. And probably the most famous example of doing that is with earthquake epicenters, because you can see the plate boundaries, the fault lines, and the pattern of earthquakes, right? They're not just random patterns. They have to do with plate tectonics, the depth, the magnitude, the position of fault lines, and also the location of nearby volcanoes. It all is spatially arranged on the Earth's surface in a logical manner. Also, though, there's a bit of unknown because we can look at the historical pattern of earthquakes and maybe predict where the next ones will be, but there's also a lot we don't know about the Earth's crust and about plate tectonics itself. Recently, I was reading an article about the Los Angeles basin and the complexity of the fault system there and the subsurface is much more intricate and complex than we even realized up to this point. So it's all part of this complex world around us, and we're trying to make sense of it with a geographic information system and the spatial perspective. So welcome to Week 2. I hope you enjoy these activities and these discussions, and we'll see you online. Thanks.